All right, we are live. What we're going to cover today: length, Pythagoras, area, surface area, and volume. Yeah, I'm recording it, so we've got it for later, so I can hear all of you. Yeah, and it's really easy. So far they've got 18 seconds of you guys talking and not listening. Let's see how we go. First thing, length is really easy. It's a one-dimensional measurement. We all know about length, don't we? Yep. One-dimensional. Way, that's very exciting. The only thing we ever have to find is when we're using length, is the distance around an object. What's that called? Yay. Perimeter. Now, when it's perimeter, it's ER, but when it's just a meter, 1 meter, 2 meters, it's RE. So remember that. Because meter with an ER means to measure. So the perimeter, distance around the outside of a closed shape. Now, books like to give you 1,000 different rules to remember and learn for perimeter, okay? And our book probably does the same sort of thing. But really, all you need to remember is that it's a distance round. So how do you find the perimeter of anything? Find the length of each side and add them together. That's the easiest way. Some people like to have like the distance for the perimeter of a square is 4 times the side. And the perimeter of a rectangle is 2 times the length plus the width. You can figure that out as you go. You don't need to memorize all of that. You just need to know what it is and then find the length of each side and add them together. That's the safest way. Sometimes they try and throw in tricky little shapes. Yes, some of all sides. Some of the lengths of all sides. That's the same thing. The only thing that has a special rule that you do need to learn is what? No, triangles got all straight edges. Circles. Circles are curves. They have a special one. Yeah. The perimeter of a circle has a special name called the circumference. Anyone know the rule for the circumference of a circle? Yeah, 2 times pi times r. You could just call that tau r if you wanted to be really cool, because that would make me happy. Well, you know. Yeah, tau, 2 times pi. We've been over that, how much better it is. But that's okay. And yes, you can also do that by going pi times the diameter. The reason we use 2 pi r is because it relates to the area formula later on. And you can see how one's derivative of the other. But basically, if you have a circumference and you find the radius, you can find the circumference multiplying by 2 pi. The only tricky shape, apart from having lots of straight edges added together, is a sector. Or I say sector now. Yeah. Alright, so yeah, this is called an arc length. That bit right there. That's an arc length. Well, that's an arc. So the arc length, and exactly right, it's what fraction of a circle have I got? Well, we break circles up into 360 degrees. So we do theta divided by 360, and then multiply it by 2 pi r. It's that fraction of the perimeter of the circumference of the circle. Pretty easy. So if you had to find the perimeter of a sector, not just the arc length, then you'd find the arc length and add on 2 times the radius. That finds just the arc. Yeah, so if you want, like I said, if you wanted the perimeter, it's got to be the arc length plus the radius times 2. Yeah. That's all there is. They're as tricky as our problems get for perimeter. Let's have a look and see if we've got any here. Let's pick something that looks hard. None of them. Wow, they're all circles. They're all pretty easy. Well, let's just do a couple before we move on. Find the perimeter of this sector. The Pac-Man one. That looks pretty cool. You can see there's already question 8, and you guys can cope with all these really easily. That's question 8 from exercise 6a. So if I want to find the total perimeter of that, well, I would find the arc length first. Why not put it there? The arc length equals a fraction of 360 multiplied by 2 pi r. Fill in the things we know. What's the angle? Are you sure? 300 degrees. So 300 over 360, you could just make it 5 over 6, but your calculator's going to do that for you anyway. Multiplied by 2 by pi, and the radius is 6. And I think you're going to find 5, 6, that'll cancel, and I'll end up with 10 pi centimeters. So the exact perimeter is 12 plus 10 pi centimeters. You could then find an approximate answer for that if you want. So when I find the first bit, the 10 pi, when I stop there, that's the arc length. So that's the distance around the curved bit. But if I want the perimeter of that shape, I need the 2 radii coming in, don't I? I need those 2 radii coming in. That's exercise 6A, question 8, part D. I labelled it and everything. It was really nice. Yeah. So you just had to add on the 2 6s. You could get the approximate answer. What's that going to be? 31.4 plus that. So approximately equal to 43.4 centimetres. Easy enough? Later on in the exercise, they give you some other interesting shapes, and you have to work that, like, you know, oh, that's 2x plus x is 3x, that's 4.5x equals 10.8, and you divide by 4.5 to find x. Composite shapes, again, pretty straightforward. Couple of questions there, but really there's nothing particularly difficult about it. So, yeah, let's go to a theorem 6.2 that you've never heard of before. Yeah. Pythagoras' theorem for a right angle triangle. Any right angle triangle. This is 6.2. The square on the hypotenuse. What's the hypotenuse, anyone? Longest side, what's it opposite? Right angle, yeah, we were doing it to death in trig, so we're all over that. The square on the hypotenuse is equal to the sum of the squares on the other 2 sides. Yeah, so most of you learn it with C. I hate it when people teach it with C, but, you know, you can't break with what people always do. But why would I not teach it with C? I always teach it with H for a good reason. Why would I teach it with H? The hypotenuse. And too many times in exams, I see people just put whatever one they're trying to find on its own and the other 2 that they're given on the right-hand side, even if they're trying to find one of the smaller ones. I see it all the time. So if you just remind yourself and call it H squared equals A squared plus B squared, you're less likely to make that error. Now, the rule is actually, and Pythagoras' theorem, is to do with the area of squares. A lot of people think it's just to do with the numbers. It's actually worded the square on the hypotenuse for good reason. It's the area of this one equals the area of the other 2 added together. Yeah. This is used every day by tradesmen everywhere. They carry around little set squares in 3, 4, 5 so that they can check that all their foundations are at right angles, that they're setting things up so that they're at right angles. Useful. It's used all the time. Yeah. Do you think our buildings end up at right angles just by luck? No, like to get right angles. Yeah, so they might even do it to make sure the wall's vertical and things like that. Yeah, it's very hard if you're just putting a post up to make sure it's level, but you can do that with a set square. I mean, they've got spirit levels as well. Yeah, they can use the spirit level as well. But when you're like laying this wall here and that wall there, it's going to look like they're at right angles, but you would check by measuring the diagonals to make sure that Pythagoras' theorem works. So it's used all the time. I don't think we need to go over any examples with Pythagoras' theorem, do we? We've done it to death and we know it. Because you will use Pythagoras' theorem later on when we do things like finding the length of the biggest straw that will fit inside this can of Coke without disappearing, you know, something like that. I don't know. So you would have to, you know, just find the right angle and do it. So there'll be questions that involve Pythagoras' theorem. Yeah, applications in 3D, that sort of thing. You've done them for years now. I don't expect anyone to have trouble with that. If you do, we'll just go over a couple when you get to them. But for now, I think that's all we really need out of 6.2 Pythagoras. What comes up after that? Area! Yay! Yep. What is area? The two-dimensional space. Yeah. A shape occupies. Takes up, whatever you want to call it. They'll have a beautifully worded textbook definition, but as long as you know what it is, I'm happy. Oh, Pythagoras in 3D, very exciting. You've done all of that sort of stuff before. None of that is new. You did it in grade 8 and grade 7, so... Wow, look at that exciting stuff. Area, yay! What do they call area? Oh, converting units, we'll get to that. Two-dimensional shape can be defined as a number of square units contained within its boundaries. They give you a bunch of rules here. And that's great that they give you a bunch of rules, and you've got a summary sheet, so you can actually write them down on your summary sheet if you want. I tend not to remember any of them because that's a lot of effort. Well, I remember one of them. And that is, and I want to show you how they're all related. Hey? Well, that's true, because that would work for all the others, wouldn't it? But basically, all of those formulae are variations on the area of a rectangle, length by width. They are all length by width. A square is length by width. It just happens to be the length and width are the same, so it comes out as s squared. A rectangle is length by width. Fair enough. A triangle is half. They call it half base times height, but if you have a look, it's a half of length by width, isn't it? Because you can see that this part of the triangle corresponds exactly to that part, and this part of the triangle corresponds exactly to that part. So a triangle occupies exactly half of a rectangle. Pretty easy. A rhombus, two ways you can do it. You can treat it like a parallelogram. If I knew the height, the perpendicular height there, and the base length, then I could just do base times perpendicular height and do it like a parallelogram, couldn't I? Well, I'm just explaining that you don't really need to know them because they're all just variations on length by width. And so if you understand where they come from, you can figure them out in seconds. Anyway, why is it half of x by y? Again, if I put a rectangle in that's x by y, can you see how I've got 4 triangles inside and they all correspond to 4 triangles on the outside? So it's half of that rectangle again. The kite, same principle, we'll just jump over to the kite. 4 triangles inside the kite correspond exactly to 4 triangles outside the kite if I make a rectangle x by y. So that's why the rhombus and the kite have the same rule. A parallelogram, if you imagine you've got like a textbook or a deck of cards, this textbook's probably a good example. The area on that end doesn't change if I push it, like if I change the angle of the pages a little bit and have it pushed over to the side. The area of each individual page is the same, so it's just sort of like being messed up. All you do is neaten it up, you've got a rectangle. That's all you're doing with the parallelogram rule. If you just squashed the sides back together and stood it up like a deck of cards leaning on its side, put them back together or a stack of paper so they're all neatly stacked, the end area hasn't changed, has it? It's still just length by base by height, length by width. So it's exactly the same. Trapezium, how is that exactly like a rectangle? Yeah, well, all I've got is just the angle's changing, isn't it? So the length of the side on the end is changing, but if I found the average width, wouldn't it then make a rectangle? And how do you find the average width of two numbers, or average of two numbers? Add them together, divide by 2. So that's all they're doing. They're adding the two numbers together, dividing by 2, so that's just finding the average width times the height. So it's the same rule for all of those shapes. So I don't really think there's much to memorize or remember. It's all there. It's just length by width, and sometimes you need to only find half of it. If you just use your brain, you'll be able to do all of those with one rule, which is nice. That works for me. Other shapes that we've got to do, you're going to know these. Circle, area of a circle, pi r squared. This is 6.3. You asked that before. Jeez Louise. And what else we got? We've got a sector. What do you reckon an area of a sector is going to be? Yeah. Yeah. It's what fraction of a circle have I got? So angle over 360, theta over 360, multiplied by pi r squared. It's that fraction of the circle. Yeah. You should have said, can I go to the toilet? So I could have done my joke on the video. That would have been better, but that's okay. Not there, Husey. That's disgusting. Oh, excellent. Now you've got to laugh when you watch this back. Yeah, and you're going to mention it. That's true. It's so... Oh, just because it's you. Will I pause here while you write all those down? Oh, you are good. Yeah, there's no need to really write them all down because you recognise them all as being the one rule, and then it's easy. So what are we going to do that's really tricky with these shapes? Maybe stick a couple together so you have to find bits of them together. That's it. That's all we can do. Area is pretty easy. One thing I will mention though is unit conversion. What do you ask me? Yeah. Theta over 360. Yeah. Yeah. Well, that was the inside too on the other one. Inside the shape was 300 degrees, wasn't it? The 60 degrees was the bit that was missing. So it's always the bit that's inside. Yeah. It's just sometimes it looks like a bigger bit. Yeah. Unit conversion. I should have mentioned this back in length, but we can do it now. Millimeters, centimeters, meters, kilometers. If you're going to a larger unit, you're dividing, aren't you? Because you'll have fewer of them. If you're going to a smaller unit, you're multiplying. So millimeters to centimeters, I'd have to divide by 10. Centimeters to meters is 100, so I divide by 100. Meters to kilometers, I divide by 1,000. Going the other way, I multiply by either 1,000, 100, or 10. Pretty straightforward. When it's an area, when it is an area, remember I said these are two-dimensional? So there are usually two measurements that I will have. I would need to multiply each one by the corresponding thing. So all I do is square the number that I multiply by. Or divide by. So you just have to remember to square the factor. So if I give you an example, find the area of this triangle in square centimeters. So there's something, I'm given measurements in meters, but they want to know the area of the triangle in square centimeters just to be difficult. How hard is it going to be? Not very. Area equals area of a triangle. Yeah, half base times height. It's half of the area of a rectangle that's made up of the base times height. So half of 4 by 2. So you're right. The area is 4 square meters. If I want to change that to square centimeters, What do I need to multiply by? Not just 100, easy. Yes. Because each of the measurements, the 4 and the 2, needed to be multiplied by 100, didn't it? So you multiply by 100 squared. So you just got to remember that. If it's square units, I've got to square both measurements. So that's a 4 and then 4 zeros stuck after it. So it's 40,000 square centimetres. There you go. It's pretty easy, isn't it? So 4 square metres, 40,000 square centimetres. So you get to big numbers very quickly. Yeah, you can do it on your calculator. You still need to know to multiply by 100 twice. If you don't realise that you've got to multiply by the factor squared, having a calculator will not help you. That doesn't have unit conversion on it. Oh, to put 4 squared and get 16, the units are squared, not the number. Your calculator is of no use to you for those questions. As excited as you are to have a calculator, it doesn't help you in that case, unless you can't go 4 times 100 times 100. There are calculators that do unit conversion, just not yours. Ah, but you don't need you need help to multiply by 100? You worry me sometimes. Let's scroll to the top, see what we've got left. Wow, surface area. We've got 2 different things to find surface area of. And 5. Oh yeah, hold on. Have you learned anything new yet? Probably not. Maybe just that every rule you have for all of those polygons that we learn the rules for is really just a rectangle, or a variation of it. Surface area. What is the surface area of something? Yeah, it's the sum of the areas of the faces of a 3-dimensional object. I can't be bothered writing that out, so let's cheat and steal their one. Surface area, a prism, and now interestingly, a prism and a cylinder are 2 different things, but essentially cylinders work the same way as prisms. So we don't, although there is a technical distinction in that prisms have parallelogram sides and cylinders clearly don't fit into that, we're going to go with the same rule for each of them anyway. So for prisms and cylinders, these are objects which have a constant cross-sectional area. So what do they feature? A constant cross-sectional area. EA. Pen playing up a little bit there. So what do we got? We could have just a nice cylinder. That's a right cylinder because it's above. You can have them like this too. You can have, rectangular prisms, cuboids or boxes. They're all the same thing. Triangular prisms. Look at those awesome drawing skills, because I think of Toblerones all the time. Actually, I don't. The Toblerones are good, aren't they? And cans of Coke. Can I scroll up? Gee. Be there. Just in case you're wondering, Gould is still in the lead, but we're not winning overall. It would be good if we could win overall, so if everyone could just get, say, 10,000 points tonight, we'd be a chance of catching up. Yeah, I know. No, Gould are killing. Gould are killing it. St. Peter's overall. This was your one chance to be a world champion at something. You could be a world champion at this, and you've thrown it away by not doing enough language. Think about it. Well, maths is coming up, and I'll be really upset. See, I don't care so much about. I do care about languages, I'm lying, but I care more about the maths, and that's coming up next term. So we've got to make sure we win that. Why would you not care about maths? Oh, languages, because it's a chance to win. Don't you want to have everyone look at St. Peter's and go, oh, they're from St. Peter's, they're that really smart school that always wins. That's what I want people to do. They don't do that.
Yeah, always. But education comes with one. We just do 1 plus 2.
Yeah, I wonder why there isn't Korean. There should be. Yes, there is. All right. I prefer. Your book will give you lots of options of rules. Is it too small? All right. Your book will give you lots of rules. One for a prism that's a rectangular one, where it goes 2 times length by width plus 2 by length by height plus 2 times breadth by height. Something annoying like that. There is one rule that works for every prism and every cylinder, so I use that one. And I only have to remember one thing. And it comes from, basically, if you imagine any of those shapes, I can form them by just folding up a piece of paper, can't I? Like a cylinder is just rolling a rectangular paper into a circular shape and then sticking a circle on each end. So why is it that I go perimeter of the cross-section times the length? Because if I unfold that side, it's just a rectangle, isn't it? The length is the height of the cylinder, or if it's lying down, the length of it. And the perimeter of it is just the other length of the rectangle. Now, it wouldn't matter if I made that a triangular prism, triangular base prism. They say triangular base, even though it might not always be sitting on the triangle. The triangle, if it's the constant cross-sectional area. The triangular one there, what's the perimeter of that form? Forms a rectangle, doesn't it? The length by the height of a rectangle. So, one rule for all cylinders and all prisms is so much easier than learning multiple rules. So I always go with that. You can learn all the individual rules in the book if you want, but personally I think you're wasting your time and you're actually limiting your understanding. If you just remembered that, you can't mess it up. Huh? What were you doing, Annika? Were you tuning out? Basically, have a look. See how, like, this is a triangular prism? If I just unfold that, doesn't the perimeter make just one side of a rectangle with the length of the height of the prism? Yeah. And if it was a circular one, same thing, doesn't it? The perimeter of the cross-section, if I unfold it, just forms one side of a rectangle, doesn't it? So a lot of people, when they're doing those triangular prisms, they find the area of each of the 3 rectangles and add them together. When you just add the 3 numbers together and then just times it by the length. No, because they're not always the same length. But you can just find the perimeter and then multiply it by how tall your cylinder is and you're done. Your prism is and you're done. So it's faster and easier. Yeah. Perimeter of the prism, or of the cross-section, times the height or length. The cross-section is the bit that stays the same shape all the way through. Prisms and cylinders have the same shape. So for this one, it'll be a triangle. But, you know, for a cylinder, it's a circle. Yeah. If I just find the perimeter of that and times it by the length. Yeah. 2 pi r h. Yeah. That's just the perimeter times the height. Yeah. Yeah, and that works for every prism and cylinder. So you don't need to learn extra ones. All right. Other shapes that we're going to do that maybe some of you remember and some of you will not. The constant cross-sectional area is the bit that stays the same all the way through the shape. So for the first two, it's a circle. For this one, I could actually choose any of the sides for a rectangular prism, couldn't I? For the triangular one, it's, you know, the triangle on each end. The cross-section's like the shape. So in the fourth one there, it's the triangle. In that one, it could be any of the sides, because it's the bit that stays the same shape from one end of the prism all the way to the other end. Yeah. So it's like if you cut it with a knife, you get the same shape all the way through. Cones and pyramids, what's special about them? They're pointy. cones and pyramids, there isn't a nice special rule to find the surface area. I would just find the area of each side and add. For a cone, it's a little bit tricky. Pi r squared, that's the flat base. If indeed it's standing on its base, but the rest of it, pi r s. That is the curved surface. And S stands for the slant height. Yep. If it rolls out, it becomes a sector. Yeah. It's a sector of a circle. Yeah. So to make a cone, you just fold the two edges of a sector of a circle together, and that then forms a cone. And S is the slant height, which is the radius of the bigger circle. That's interesting, I know. Pi r squared plus pi r s, surface area of a cone. All the other ones, just find the area of each side, add them together. If they're all the same, you can use multiplication to cut down on your work time. But there's no other real way of doing it. Yeah. We've already done all of chapter 5 over the last 2 weeks, but we can do it again. Alright, one other special shape now. Sphere. Not a sphere, as some people like to say. That's okay. I know, dude. Surface area of a sphere is 4 pi r squared. 4 circles added together perfectly form a sphere. Oh, you people are very fussy. I don't know. I don't care. I think this is actually the last one. But well, I'm doing it out of order because I don't like their order as much as mine. That is a circle. Well, then you draw your circle perfectly. That's a circle. So, more rules to learn. If it was a hemisphere, it'd be half of that. If it was part of a sphere, you just find a fraction of it. Yeah, you just find a fraction of it. Pretty easy, hey? No, have you done any volume yet? So why are you trying to cut? Why are you trying to stop short? We are doing maths. What do you call this? It's so funny. Everyone says, "Oh, sir, can you teach on the board? Can you teach on the board?" As soon as I do, everyone wants to do something else. You drive me nuts. Yeah. S. S for slant height. It's just about the only rule we ever use a slant height for. Alright, volume, the amount of space in 3D. I don't know. Sure. Steady on. Don't provoke her, she's a ranger. It's going to hurt you. Oh, well. There are other ways. You don't have to throw things at them. Oh, really? Why is it that our concentration limit is about 28 minutes? Well, actually it's 35, but it's a bit of a worry. This is so easy. Do we remember all of this still? Okay, boss. Volume is easier than surface area, so it's no surprise. Alright, we've got to do the 3 different sections again. First one, prisms and cylinders. It's a V, it's not an I. Yeah, it's a number 1. Yeah, it's a Roman numeral 1. You can do Roman numerals on Education Perfect still for about 1 day and 8 hours, so don't be afraid to get 1,000 points on them. Just if you want to. So, volume is just the area of the cross section, so usually you call that the base, like usually you'll see it area of base times height, but it's the area of the cross sectional times the length slash height, whichever way it's, depending on which way it's lying down. Interestingly, if I was doing that one, I count the length as the perpendicular length, or the perpendicular height. That is how far the cross-sectional shape moves. It moves vertically that far. So I would do the area of the circle multiplied by the capital L there, that would be my length, because it's how far it moves perpendicular to where it started. If it goes off at an angle, it's still just the actual perpendicular height or length. Actual perpendicular. I should have had the video on then so you could have seen my hand actions, but you missed it. Prisms and cylinders, really easy. Alright, the pointy ones, what are they again? Cones and... yeah. You can draw whatever you want, but it's still cross-sectional area times length. Doesn't matter. Boys, no hugging. Why are you hugging him? Is he stealing from you? Cones and pyramids are basically derived from prisms, and they occupy exactly 1/3 of the volume of the prisms. When they go to a pointy bit, isn't it? Isn't that a bit weird? They occupy 1/3. You might think it's a half, but it's 1/3. There are a lot of really cool, interesting proofs that we might look at after the exam for a bit of fun, just so you can see why it's that. Oh, because I can make it fun. Because you could do it with chocolate and lollies. Yeah. Oh, yeah. Okay, see. Maths is fun. Yeah. Okay. But, you know, you don't want to do it, so it's alright. I don't want to bore you. I'll just have the chocolate and lollies to myself. And we could make cones out of pizza, because they're sectors. Oh. Now we're talking really good. These are good. These are good ideas. Just tell them not to cut it, and then we can cut our own sectors and make pizza cones. And then you could fill them with something and eat. Oh, we could. That's a strange choice, but that would be pretty cool. You don't like them? Oh, you've heard chicken nuggets. That's very cool. Do you know that they have Did you know they also have stuffed crust pizza, but they've stuffed it with meat pie? I heard that on the radio yesterday. That is insane. I think I'd give it a go. I'm not sure that it'd be that good, but I'd give it a go. Alright. Cones and pyramids, 1/3 of the volume of a prism. Sphere. Spheres. Volume is 4 over 3 pi r cubed. Now when you get to Maths B and we do some calculus, we'll teach you how that works and why it works that way. But for now, we'll just go with it. 4 over 3 pi r cubed. It's a little bit weird, and as I said before, we could show you with some calculus, or we could just do it with lollies later. But for now, calculus is just awesome maths. And that's it for the whole chapter. And then what do? They ask you variations on those rules. But really, you've only got a few rules. Area of a rectangle, special rules for prisms, surface area, find the area of each side, add them together, and volume areas. Area of the base times the height, pointy ones, it's only 1/3 of that, and spheres are 4/3. Last thing, if I was doing unit conversion, because we all messed it up on our last one, millimeters, centimeters, meters, kilometers, these things divided by 10, divided by 100, divided by 1,000. Because I want you to realize that just because it's a volume doesn't mean we need to learn. Like a lot of books show them with different numbers here. It's always just 10, 100, and 1,000. And when they're units that are cubed, what do I do with each of those factors? I cube them. One-third, because there are really cool proofs of that, and we'll look at that after the exam. But yeah, well, you can go away and prove it for homework if you want. Okay, so just accept it for now, use it, get the questions out of the way, but we will look at it. But some of the proofs of these things are beyond what maths you actually need at the moment. But I still want to show you, so I will do it, but we'll do it after the exam, because it's pretty cool. And there are lots of different ways of proving it too. So. Yeah, 4 circles, I know. And multiply by r again, yeah. It's crazy, hey. Alright, that's it. That's chapter 6 in 42.5 minutes, nearly 43 minutes. Go away and do all the questions. I know Harry's got some questions for me, and we will do maths again later. Have fun.